Okay, this is a quick tutorial for Cisco subnetting. I'm going to do a whole bunch of tutorials on Cisco subnetting for the CCNA 1 class. There's 4 sections to the CCNA, and CCNA 1 is networking fundamentals. So this is my first tutorial. And first of all, if you want to understand Cisco subnetting, you have to understand how to work with binary counting system, number system. So I put up here binary versus decimal. And this is the hang-up, is that we're used to working with decimal counting, right? We do everything in decimal. So as soon as somebody says, hey, I want you to think and use a different counting system, we just can't do it because we're just so used to working with the decimal system, right? And so it becomes hard. So first of all, what's the differences between binary and decimal? Okay, so in binary, we'll start with this. In the binary system, the binary system is a base 2 system, base 2. Okay, and what does that mean? That means there's only 2 digits, a 0 or a 1. So you've heard everybody say in computers everything's ones and zeros. Well, or it's a binary system. That means there's only 2 digits that the computer really knows, and that is zeros and ones. So it's base 2. All right, simple enough. Now, decimal system is different. Okay, decimal system is base 10, which means there's 10 digits that we use to count. We use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then when we want to say 10, we use a combination of a 1 and a 0, right? So, but there's only these numbers are the ones we use. All right. So we'll go here. We say, let's see here. No, that's not what I want to do. Yeah, I'll do it like this. Okay. So in binary, I'm going to bring up this picture right here now. In binary, base 2, 2 digits, 0, 1. So if I write out this number in binary, 1, 0, 1, 1, 0, 0, 1, 1, it's actually in decimal, this would be 179. Okay, and how does that work? It works because of place values. There are place values that these numbers correspond to, and this is essentially a little map for the place values, but it'll be easier if we first talk about it in decimal. So I'll go down to decimal and talk about the decimal number 179. So in decimal, with the number 179, okay, there's the number 179, right? You have the ones place, right? The tens place, the hundreds place, the thousands, 10,000, 100,000, and a million. And what that means is, this is the 10 to the 0 place, right? 10 to the 0, 10 to the power of 0 is 1, 10 to the power of 1 is 10, 10 to the power of 2, or 10 times 10 is 100, 10 to the power of 3, or 10 times 10 times 10 is 1,000, 10 to the 4, 10 times 10 times 10 times 10 is 10,000, and then 100,000 and 1 million. So what you have here is, to do the number 179 in the decimal counting system, that means we have 1 is in the hundreds place, so that means we have 1 times 100, and we have 100. And then we have 7 in the tens place, or 7 times 10, right? And we have 9 in the ones place, or 9 times 1, or 100 plus 70 plus 9 equals 179. Of course, we learn this when we're very young, so we just accept it. That's 179, right? Oh, 100, it's a hundreds place, 7 in the tens place, and 9 in the ones place, right? Which means 1 100, 7 tens, and 9 ones, right? 179. Well, in binary, it's a little bit different. In binary, the place values are different because it's base 2. So instead of 10 to the 0 and 10 to the 1 and 10 to the 2, it's 2 to the 0 is the ones place, 2 to the 1 is the 2's place. 2 to the 2, or 2 times 2 is 4, 4's place. 2 to the 3, or 2 times 2 times 2 is 8. That's the 8's place. 2 to the 4th power is 16. 2 times 2 times 2 times 2, and so on and so forth. But notice the difference here. Instead of going up by multiples of 10, it's going up by multiples of 2. So each place value in binary doubles the previous. So 1, 2, 4, 8. 2 times 8 is 16. 2 times 16 is 32. 2 times 32 is 64. 2 times 64 is 128. The next place would be 2 times 128, or 256, right? So it's quite easy that way. Well, here's our number, 10110011. So I put them in here, 10110011. And what does that mean? That means we have 128 in the 128th place. We have nothing in the 64's place, but we have 1 in the 32's place, or 1 times 32. So we have a 32. We have a 1 in the 16's place, so we have a 16. We have 1 in the 2's place, we have a 2 right here. And we have a 1 in the 1's place, so we have a 1. And it's always 1 times 128, 132, 116, 1, 2, and 1, 1, or 128 plus 32 plus 16 plus 2 plus 1 equals 179. All right, and that's it. That's essentially it. That is the counting system for binary, right? There it is in decimal, right? And here it is in binary.